In section 6.4, we're going to continue our discussion of the fundamental theorem of calculus, but in this video, we're going to look at the second fundamental theorem of calculus. So we're actually going to work through these problems the long way so that we can come up with a process for how they have determined what the second fundamental theorem of calculus would be. So let's look at, we want to find the derivative of the integral from 0 to x of 2t dt. Well, first of all, doing the antiderivative of 2t, we get t squared, but that's going to be evaluated at x and 0, which gives me x squared minus 0, which would be x squared. But then I need to take the derivative of that, and the derivative of x squared is going to be 2x. Let's look at another one. Say we want to find the integral or the derivative of the integral from 5 to x of sine of t dt. Well, we know that the integral of sine of t is negative cosine of t, but that's got to get evaluated at x and 5. So that's negative cosine of x minus negative cosine of 5. But minus negative is plus. So then we get negative cosine of x plus the cosine of 5. But I'm going to take the derivative of that. And we know that the derivative of negative cosine of x would be positive sine of x, and the derivative of the cosine of 5 would be 0 because cosine of 5 is a constant. So now what we want to do is focus on the answers that we got for these problems and then what the original problem was. So looking at this first one, our answer was 2x, and our problem, the integrand, started as 2t. So notice that what we've done there is we've just changed the problem from being about t's to being about x's. So we've just replaced the t's with the x. If you look at the second one, our answer was sine of x, and our integrand was sine of t. So again, if we replace the x with the t, or the t with the x, we would have our answer. Now, looking at the second fundamental theorem of calculus, it says, if you take the derivative of the integral from a to x of f of t dt, you get f of x. All you have to do is put in the x for the t, and that will be your answer, which should make sense when you think about the fact that the derivative and the integral, which is also the antiderivative, would be inverses of each other. So we could imagine those would cancel each other out, and then we would substitute in f of x minus f of a, but because we do a derivative, the derivative of f of a, which would be a number, would just be 0. So we would just get f of x. So let's wrap up this video with just a couple examples to make sure that we have our concept here. So if I wanted to do the derivative, let's say from 2 to x of the square root of t cubed dt, that's going to end up being the square root of x cubed. We replace x's for the t's, and that's our answer. What would happen if we had d dx of the integral from x to 5, let's say, of tangent 3t dt? Well, because our limits of integration are reversed, we need the 5 on the bottom, the x on the top, we could rewrite this as the integral from 5 to x, but remember we have to do the opposite or the negative of our problem. We had a property earlier in this chapter that says that we have to change the sign of our answer. Well, the integral now would be negative tangent of 3x.